In the previous video, we looked at how electrons in atoms are usually in the ground state. That means they're in the lowest available energy level. So this first energy level was empty. So it's available, and this electron, if it's in the ground state, is normally going to be here. And we looked at how this electron can receive energy. It does this from either being heated or it does it from being zapped by electricity. And when it does this, we say the electron jumps to a higher energy level. Now, it might go here if the energy was that amount, or it might go here if the energy was exactly that amount. Remember, it will never go here. That is not allowed, okay? Because electrons can only have a specific amounts of energy, and those amounts are shown by these circles. Okay, so we say that the electron jumps to a higher energy level. So say it went to here. Now the electron is in the n equal to 3 energy level. How do I know it's n equal to 3? Well, this is n equal to 1. This is n equal to 2, and this one out here is n equal to 3. So we say the electron is now in the n equal to 3 energy level. And that jump, you sometimes hear that called a transition. So we say that that was an electron transition. Now, once the electron is out here, I'm going to get rid of some of this mess. Once the electron is, oops, don't want to do that. Once, I'm going to leave that there because it's not going to play ball with me. Once the electron is out here, like this, it's unstable. And eventually it's going to fall back to a lower energy level. Okay, so it's going to make another transition and it's going to make a fall. So say the electron falls from there to there. Okay, now it has less energy than it did when it was in the n equal to 3. So where did that energy go? Well, that energy is emitted. This is emitted energy. Okay, so the energy is emitted. Let's quickly look. Here are 5 energy levels shown. Here's n equal to 1, n equal to 2, n equal to 3, n equal to 4, and n equal to 5, and so on. And each of these arrows shows an electron transition. So here we see the transition from n equal to 5 to n equal to 4. Here we show n equal to 5 to n equal to 3, and there's n equal to 4 to n equal to 3, and so on. So hopefully you're getting the idea. And we said that sometimes we can see these transitions in the form of bands in an emission spectrum. Okay, so we can see the black background and just specific colors. What's important to know here, though, is that this here is something that's called the electromagnetic spectrum. This is the electromagnetic spectrum. I'm going to be quiet for a minute, let you have a look at that. Okay, so what the electromagnetic spectrum is essentially, it's just pure energy. And it's energy of different frequencies or different wavelengths. Okay, so all this energy, or energy in the form of waves, is this massive spectrum here. Okay, some down here we see the really long waves. These have a very long wave. These are called radio waves. And you see up here the really short waves. These are gamma rays and X-rays. These are really short. So as you can see, the wave isn't as long anymore. This portion in here, only this little section here, this length of waves, that's what we call visible light. So we can only see a very small portion of the electromagnetic spectrum. Only the measurements that we see in here, 700 nanometers, 600 nanometers, 500 nanometers, 400 nanometers. That's the range of colors we can see. Anything outside of that, we cannot see. It doesn't mean it's not there. It just means our eyes aren't designed to see those frequencies of waves. So that those energies are all around us, but we can't see them. And as you can see here, either side of the colored bands, there's a zone called infrared. And again, this is energy in the form of waves that we aren't able to see. Our eyes aren't designed to see them. And at the other end, beyond the violet, so in other words, this is violet, the last color we can see. Ultraviolet, ultra means above. So above violet is like beyond the violet colors, we can't see that. Same as this is called infrared, it's beyond the red, so we can't actually see these colors. Doesn't mean that they're not there though. So what's important is if we go back over here, we see how the different transitions create different light, if you like, okay? For example, if we see any transition that comes back to the n equal to 3 energy level, so here's n equal to 5 to n equal to 3, and here's n equal to 4 to n equal to 3. These will always involve giving out of waves that are in the infrared portion of the electromagnetic spectrum. What does that mean? Well, it means there's energy moving away in waves, but our eyes can't see them. Okay, so that's infrared. This, we can also see this then if we look at electrons returning or dropping to n equal to 1. So look at all these transitions, n equal to 5 to n equal to 1, n equal to 4 to n equal to 1, n equal to 3 to n equal to 1, n equal to 2 to n equal to 1. All of these transitions always involve light given out, but the light or the energy that's given out, the waves that are given out, are in the ultraviolet portion of the spectrum. And again, our eyes can't see ultraviolet light, so we can't actually detect that. It would be there if you had a camera that could pick up UV light, you would then see it, but our eyes can't see it. So that's where we're really interested in these transitions, all transitions that end up with the electron falling to the n equal to 2 energy level. So n equal to 5 to n equal to 2 it is kind of shown by a blue light. N equal to 4 to n equal to 2 is shown by a green light, and n equal to 3 to n equal to 2 shown by the red arrow here. All right, so always n equal to 2 is the one we're interested in. We say it's responsible for visible light. Visible light. These are the transitions that we are able to see. Only the ones that drop to n equal to 2. So there's a name given to this. We call this the Balmer series. So the Balmer series of transitions are ones that fall to n equal to 2, and these are the ones that we are able to see. Paschen series, these are series of transitions where the electrons fall to n equal to 3, and these are in the infrared region of light. We can't see infrared. And you see the Lyman series is the electrons that transitions to n equal to 1, and the light is always UV. Again, it is light being given out, it is energy being given out from electrons, but we're not able to see it. This is definitely the most important one. Balmer series, that's the one we're most concerned with because that's the ones we could see. Balmer series result from electron transitions back to n equal to 2, and that's what produces visible light. Okay, so a couple of questions to do there. If you're following along in the booklet, sorry about that now, we'll find them again. Here we go. If you're following along in the booklet, go ahead and open it. You can work from there, 214 to 217. If you're not working in the booklet, you can go ahead and pause the screen and do them questions. And my class, we'll go through them in class the next day. Okay, thank you guys. We'll see you then.